what will happen is that you clear the step 2 also. Fine. No. So the first step was to check whether each of the right side contains single element. Yes, this contains single element. So you switch to second step where it said that if any of the x side, any of the left side contains two or more attributes, then you have to check whether any extraneous attribute was there. So only one was there, extraneous. Only one was there where left side contained two elements. This one. So you checked that A was extraneous. You removed it. So after that, after step 2, you have this one present with you. Then the third step is check whether any of the function dependency out of these three are redundant. Redundant means not required. That means this can that can be derived from the other functional dependencies present in that. See here, one functional dependency is B deriving A. Okay, consider this one. Consider second and third. Third one says B deriving D, then D deriving A. So by transitive, B derives A. Getting or not? See here, B deriving D, D deriving A. So applying the transitive rule, you get B deriving A. So this one is already getting derived from these two. So here these two are sorry, this one is not required because you can always get this function dependency by these two. So remove this one. So finally you will be having only these two function dependency. Okay, you started with this one. You are trying to find the minimal cover. This is the minimal cover. There are three steps, as I told. First thing is you have to check whether each of the functional dependency present in the set are having at the right side single element or not. If they are not single element, what you have to do, I told that you have to fragment it. You have to apply rule number 2, IR2, that says decomposition. That means if there are multiple attributes, suppose this would have been D deriving AC, you would have written it as D deriving A, D deriving C. Okay, four functional dependency would have been there. But in this case, there is that is not present. If it would have been present, you have to do it like that. Then the second step is check the left side. If there are multiple attribute more than two or more than two, you have to check which are of them are redundant. Okay. Then the third one is removing that functional dependency which is redundant. That means which is not required. Here, what you are removing the functional dependency itself. In the step 2, you are removing the attribute, the redundant attribute, which was A. Then in the third step, you are removing the redundant functional dependency, which was this. This is not required because you can always derive this one from this two. Fine. That was the concept of minimal cover. And this algorithm is for the finding the key of R. Given any relation, a functional dependency set will be given. Based on that, you have to find which attribute or combination of attributes can be the key attribute. Okay, so how do you do that? Finding the closure. So take any combination of any attributes, whichever the closure of whichever attribute or attribute set contains all the other attributes in the relation, that will be a key attribute. Okay, the example is already explained in that video, so I am not going into that detail here. So, no doubt now. Okay. Mm, Now the most important part of the course, normalization, that purely depends upon the key concepts and the functional dependency concepts. Okay, what do you mean by normalization? See, to start with, if you remember how a relation or how a table is built, you don't directly sit for writing the code for a table, right? You start with ER diagrams. Okay, in ER diagram, you say that which are the relation, which are the tables, what are their attributes, which type of attribute, whether that is composite or multi-value or derived or store. Fine. So from that, you map it to relational model. That was said in ER diagram to relational model mapping. That means seeing the ER diagrams, you build the relation tables. Fine. Now, after you build the tables, who will say that your tables that you have built are proper, or this is as per the rule stated by EF code in 1972? Okay, how are you sure that your relation that you have built is properly built or properly designed? For that, you have to. There are some standards. Standard means there are some labels. Up to what level your design is reaching or meeting. Like in software design, you have CMM level 5. You might have heard about this company is Six Sigma company, or this is meeting CMM level 4, 3, 5. These are all labels. We start with say 1, 2, 3. If a company is 1, CMM level 1, and if a company is CMM level 3, then of course the CMM level 3 company is better than CMM level 1. Okay, so there are various levels of confirmation to the quality. Suppose your schema or your database that you have designed meets normal form 2. There I have designed a data set which meets normal form 1. Then your design is better than my design. Okay, so 1, 2, 3, 4, 5. There are 5 levels of normal forms that comes under this normalization concept. Okay, the highest you have attained is the better. Fine. Now, what do you mean by normalization? So you can see the screen. The definition says it is a process of analyzing the given relation schemas based on their functional dependencies and primary keys to achieve the desirable properties of minimizing redundancy, minimizing insertion deletion anomaly that were discussed in the last class, also last to last class, and avoiding the null value. That means whatever design principles that you have seen, the 4 design principles, it should cater to or it should meet. Okay, so normalization is nothing but a process in which you are designing such type of database which conforms to the design principles or which are perfect. Okay, so how do you ensure that? Now you go on checking whether your relation meets normal form 1. If it meets 1, then go to normal form 2. If it meets 2, go to normal form 3. If it meets 3, go to 4. Okay, likewise, the higher the normal form it attains, the better the design. Okay, that's why it is written here. The definition is the normal form of a relation refers to the highest normal form condition that it meets. That means if it is meeting normal form 4, okay, that means automatically it is meeting normal form 1, 2, 3. Okay, if it is meeting normal form 2, automatically it is meeting normal form 1. So normal form of a relation means is the highest normal form that it can attain. Okay, uh, Fine. So now you are clear about what I am saying about normalization, why you need normalization, just to ensure that whatever design you have done for the database are proper. How do you know proper? Proper means it conforms or it adheres to the design principles. What are the design principles? Now, there are four design principles: avoiding generation of spurious tuple, avoiding generation of null values, avoiding insertion, deletion, update anomalies, and proper design of the attributes. Four design principles were there. So the basic aim or the main aim of normalization is that every database or every relation that you are designing should be conforming to these four rules. That's it. Okay. So why in the process you will also find these two property will come up: non-additive join or lossless join property and dependency preservation property. You will see that for attaining normalization, suppose a relation is given, okay, that is not in proper form. That means suppose I have designed a relation schema or a database having suppose say 8 or 10 relations, but it is not proper. I gave you to design it properly. So what you will do is that you will try to partition it. You will try to divide it so that it each of the divided relations will meet the design principle. That is the way. That means given a relation, if it is not meeting the normal forms, any of the normal forms or some of the normal forms, you go on dividing it, okay, or decomposing it. In the process of decomposing, it may happen that some of the functional dependency may be lost, but you have to ensure that as less as possible functional dependencies are getting lost, because functional dependencies are are a constant which are good for the relation, okay, like your primary key, foreign key, integrity constants. Those are all constants. Constants are good for the relations. If you are building within constant means you are building as per the rule. That's why functional dependency is a constant which should be there in your dependent in your relation. It should not be lost. Okay, suppose you are having 7 or 8 functional dependencies, but in order to attain normal form, you will see the process. In order to attain normal form, some functional dependency will be lost. That is mandatory. You have to lose them, but you have to try that as less as possible functional dependencies are getting lost. Are you all listening? This is like one-way communication only.
Yes, sir.
Okay. Uh, Fine. So these two property we will also take care of. This one is dependency preservation. Dependency preservation means, of course, this is functional dependency preservation. Another one is not a non-additive join. That means that was the case of spurious tuple. I told I will be telling it later. Spurious tuple means when you are combining two relations, existing relations, you are finding a third relation where some of the rows are not even present in table number 1 or table number 2. The information was not at all present, but it came up. While combining two tables, this will happen that some of the rows will automatically come up which are actually not there in the original relations. So those are wrong tuples, wrong information, or called spurious tuples. So that has also has to be avoided, because when you are dividing one table into multiple tables in order to attain normal form, then when you want the combined information from both of them, you have to join them, and in the process of joining you may get this situation that there are some additional tuples which were not originally in the previous two relations or in the previous relation. So those are spurious tuple. So that is non-additive join, means you are not adding anything. You should ensure that you are not adding any extraneous tuples or any wrong information. That's why it's called non-additive join or lossless join property. That means there should not be any loss of information. Presence of wrong information is also termed as loss of information in database. Okay, your database should contain only the correct data. There should not be any false or any wrong data in it. If it is having wrong data, then also it is called data loss. Okay, those concepts you have to bear in mind. Fine. So now we are ready for normal form. Keys and attributes you already know. Let's go to the first normal form. Yep. The font definition is this is the definition of first normal form. It says that all the relations should have only atomic attributes. Atomic means which should be undivided. Okay, that means the attribute values within the tuple should be undivided. See one example here. Here, how many values are there in this? Am I joining again this time? Yeah, here in it. You see here, how many values are there in row 1 under D location?
Sir, screen is not visible.
Screen is not visible. Now is it visible? Now is it visible or not?
No, sir.
You only not visible, I
Yeah,
guess.
it is
It's
visible for me.
it's visible, sir. It's visible.
You disconnect and connect again. Okay. So what happens is that I am talking about first normal form. First normal form says that any value present in any of the tuple under any of the attribute should be undivided. That means should be atomic or should be single value. You cannot keep three values in one row under a single column. Okay, it should be like this. This is a single value or atomic value or undivided value. Okay, this is not allowed. If your relation is having this type of design, this is not allowed. This may be the case because D locations are a multi-valued attribute. Research department is present in three locations, here, here, and here. Okay, so of course this has to be stored, but you cannot store it like this. The EF code rules that were proposed in 1972 does not allow this. So this design is not as per the standard. You have to reduce it into other form. Other form means you can keep it like this. This is one solution. Here what you did is that same things will be there. In one row you keep Bel Air, in another row you keep Sugarland, in another row you keep Houston. Okay, so now all are single value or atomic value. Got? Now this has been changed to this relation. Getting? This was the problem, that you had under one row, one attribute, you got multi-value, or these are attribute values which can be divided further. But 1NF says that any relation should have only atomic values under an attribute. Okay, so this is one solution, but this solution has some problem. Can you identify what is the problem if you are storing like this? Of course it is in 1NF now. That means your values, all the values present in any of the tuple under any of the attribute are undivided or atomic, but it is having some other issue. It is in 1NF, no problem, but it is having some other issue. What are the issue? What is the problem we are seeing here?
So there
There
are
is no
three rows of
primary
the
key
same data,
Yeah, it is there are
repetition of the rows.
there is redundancy of data. Okay, you are storing the same thing again and again. Research department number 5, this, these are getting repeated. So suppose there are 16 or 18 rows like this, then you'll be having 48 number of extra rows. For each of them you have to repeat it, so you assume that how many extra data will be coming up in your relation. Fine. Okay. There is another example, then there is another solution also, it is not mentioned here. I can write it like this. Let me check whether it is given here. No, it's not mentioned here also. Okay, fine. Can I write, there is another solution to this. Like I will be writing here D location 1 in one column, another column I will be designing here D location 2, another column I will be writing here D location 3. So what will happen is that Bel Air will be in 1, Sugarland will be in D location 2, Houston will be in D location 3. So that solves my purpose. That means that new relation that I built with 3 D location column, D location 1, D location 2, D location 3 is in 1NF. That will also be a solution. Getting my point? That means in that case I will be writing this single row only, this one only. But D locations will not be there. There will be D location 1, D location 2, D location 3. So in D location 1 I will keep Bel Air, Stafford, Houston. D location 2 I will keep Sugarland, null, null. D location 3 I will keep Houston, null, null. Because these department have no D location 2 and D location 3. They have only D location 1. For this only I have got D location 3. So assume that one department is present in suppose 18 location. So there will be 18 columns here. D location 1, 2, 3, 4 up to 18. So all of them will be occupied with the 18 values for the department. But what will happen for these cases where there is only one location present? All of the value will be null, 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 null. Getting? But if you are having so many nulls, it will again deviate from the rule that was given, that avoiding null values. Getting my point? Any any doubt in this, or should I explain it in pen, on pen and paper? Or are you getting what I'm trying to say? Let me draw it then. Are you seeing the screen? Can you see the screen?
Yes, sir. Yes, sir. Yes, sir.
Say I have a table like this, okay? Serial number, name, salary, location. So serial number 1, 2, 3. Name is X, Y, Z. Salary was say 15,000. Location was A, B, C. Here only one location. Here only one location. Okay. Now these two were suppose not there. Okay. So this particular design is not meeting the requirement because here I am storing non-atomic values under a row, under a attribute. So in order to meet the requirement, I can do in one way, that I can represent it in multiple rows. Like I can write, I can insert more rows here. Okay, I can write one here, one here. X will be repeated. Sorry, X will be repeated. X will be repeated. Here, this one also will be repeated. This was the first case. Then here I will keep B. Here I will keep C. This is one solution. But you told that this is redundant. These information are getting repeated. So this is not allowed. Fine. So I will remove this two. Say I am opting for the second option, that I am creating two columns. Okay. Here this I am marking as location 1. This I am saying location 2. This I am saying location 3. So here I can keep E. Here I can keep C, because there are 3 values in this. I kept A here, location 2 is B, location 3 is C. But there are no location 2 and location 3 for these rows. So here I have to keep all. Yes or no? Suppose there are more rows. Okay. All of them have got single location. Then all these will be null, 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 null. Yes or no? These all will be null. These all will be null. Getting? So for accommodating this one, you are inserting so many nulls into the database, which is not allowed. So these are also bad design. So first two design that we saw to meet normal form 1 is not proper. What you need to do is that the accepted format is like this. Suppose here serial number, or suppose here student number. Student number is the primary key. Then I have to form another table. Sorry. I have to decompose this table into two tables. Are you seeing the screen?
Yes, sir. Yes, sir.
Got? This was my previous table. Okay, in order to accommodate this one, I created another table with the primary key of the existing relation and the multivalued attribute that was present here. So this one will be removed from here. Now from the previous table you got two tables, this one and this one. Now both of them are in one normal form, because there is no multiple attribute or multiple value under a single attribute. And you also reduce the redundancy. Here you see how many are repeated. Only this one is repeated. Previously entire whatever attribute you are having, all were getting repeated. 1x, 1x, 1x 15k, 1x 15k, those were getting repeated. Now only this much repetition, only two value are getting repeated. That is allowed. Fine. So whenever you are having multi-valued attributes like this, you have to design a separate table for the multi-valued attribute with the primary key of the relation. This was the primary key there. Okay. Now once you take this onto this table, this cannot be the primary key alone because here it is repeated. So both of them will be combinedly the primary key. Got? So this is the third option you have for reducing a given relation into one normal form. I showed you three options. One is with one was filled with redundancy, second was filled with null values. Third one is acceptable because it is having no null values and very less redundancy, which is allowed. So you deduced or derived these two tables from the existing single table. That's why this is called normalization. That means in the process of normalization, you um fragment one table into multiple tables. There will be cases where you'll see that it may be divided into three or four or five number of tables also. Initially you'll be given one table. At the end of suppose achieving normal form 5 or 4 or 3, you will be having more than 7 or more than 8 tables. All are meeting the requirement, all are meeting the normal forms. Fine. Clear with normal form 1 or any doubt? No doubt? Okay. It's not that hard. So having no doubt is okay. Fine. This concept you already I have told that prime attribute means an attribute that is a member of the primary key of a relation. That not always primary key, that can be any key, that can be a candidate key also. Prime attribute means that can be a part of candidate key or a super key or a primary key or any key. Okay. So function dependencies. Let me take the attendance. System you're saying. Yeah, attendance is taken. So doing the lab or not, the lab commands you can also run on the virtual simulator that I gave yesterday. That's quite good. You can save the session, you can save whatever tables you have created. First I tried, I did myself, then I thought you can also work on that. If you are not able to configure SQL on your system, you can use that. Okay. So experiment 1 and 2,
Sir, can you send that link? Link.
it was there in the Google Classroom, no?
Okay.
Yeah, it was there in the Google Classroom, September 16. You see it, virtual lab, use it. The manual is also there. Any doubt anywhere, you tell me. I will access the system. I will access your system and also show there. No issue. We can do it combinedly. Fine. So any doubt you can write in the Google Classroom. Assignments by tomorrow. I guess I have given tomorrow time. I forgot exactly. Okay. So disconnecting.
Bye bye.